So, good afternoon, everyone. Myself, Asif Raza. I am a PhD scholar from Department of Civil Engineering, IC Bangalore, and we'll be having discussion sessions every week on Saturdays from 4 to 6, and the course is Strength of Materials, and the course instructor of this course is Professor Shriman Kumar Bhattacharya. He is a professor from IIT Kharagpur. So what we'll do every session is initially I'll discuss assignment questions of the previous week, and in the later half we'll discuss questions relevant to the assignment in of the current week. And if you guys have any doubt pertaining to the lectures of the current week, you can ask that too also. And students are encouraged to like use the discussion forum as much as possible so that the TAs available can clear your doubts there also. So uh, without any delay, let's start. So first we'll discuss questions of week 0 assignment 0. If you guys have any doubt anywhere, you can just uh, jump in and ask. So the first question is the unit of second moment of area is, and options are kg meter square, meter to the power 4, option C is kg per meter square, and option D is meter cube. So I would ask my audience to they can reply in the chat box what do they think, what is the answer. So Imani has given option B. Uh, what about Mongchen? Yes. So both of them has said option B. So that is correct. Second moment of area, and that is like I, and that is given by A R square. So both has like area has a dimension of L square, or maybe I can say meter square, and R has a dimension of meter as well. So squaring them both, it will give me as meter to the power 4. So option B is the correct answer. Now let's move on to the next question. Which of the following is the SI unit of moment? Option A is Newton meter, option B is kg meter square, option C is Newton meter square per second, option D is Newton meter per second square. So answers. Yeah, so everyone has said option A. Yes. So moment is what? It's equivalent to torque, and that is like R cross F, and R is having a dimension meter, and F has a dimension as Newton. Force, F is force. Force has a unit as Newton, or kg meter per second square, right? So either it would be Newton meter, and if I go through this, so through that R cross F will have a dimension as m cross kg meter per second square, and that will give me kg meter square per second square. Yeah, so if we can see, option A is the correct answer. So yeah, option A is the correct answer. Other answer would be kg meter square per second square. Okay, let's move on to the next question. Question is the moment of inertia about x and y axis of a planar section are 21 meter to the power 4 and 24 meter to the power 4 respectively. The polar moment of inertia is, the options are 5 by 4, 29, and 45. So what do you think? What is the answer, and how would you get it? Like, uh, what's the theorem? You guys there? No idea. Okay, no problem. So the question is saying we we have a moment of inertia as Ix is equal to 21 meter to the power 4 and Iy is equal to 24 meter to the power 4. So this could be like take a random body and uh, x-axis. Yes. So about this x-axis, it is having a moment of inertia as 21 meter to the power 4 and Iy as 24 meter to the power 4. The polar moment of inertia is this about this axis out of this plane, say IO. So using perpendicular axis theorem, IO is Ix plus Iy, and that is 21 plus 24, that will give me 45 meter per four. So this is answer. Yeah, so option D is the answer. I hope this clarifies. Okay, moving on to the next question. Question is Poisson's ratio is the ratio of what? The options are it's a ratio of lateral stress to longitudinal stress, it's a ratio of longitudinal stress to lateral stress, or it's a ratio of lateral strain to longitudinal, or longitudinal strain to lateral strain. So Himani has given option C as her answer. What about Wang Chen? Yeah. So you guys, I think you know this. So it's a direct, straightforward answer. It's a ratio of lateral strain to longitudinal strain. Let's move on. Now the question is, okay, I'll zoom in a bit. The moment of inertia of a rectangular section 20 mm by 40 mm about the axis passing through the base of shorter dimension is, and the options are all these four. So it would be tough to say directly, so I would try to solve. Okay. So the given question is we have a rectangle of size 20 mm by 40 mm and the axis passes through the base of shorter dimension. Okay, so I'll take uh, this as the rectangle, and my this is having a dimension as 20 40 mm, and the axis passes through this base of this. So this is I'd say I1. Okay, so we need to find this I1, and okay, Himani is saying option B as her answer. Let's see, let's work it out. So we need to find the moment of inertia about this of this I1. We need to find the I1, and I1 would be, so before that Ix, like through this center, this is Ix. Okay, so Ix is, if you recollect, it is what, BD cube by 12. If you know the formula of moment of inertia of rectangle, it's BD cube by 12, and where B is this and D is the depth. So substituting those values, will have 20 into 40 cube by 12 mm4. Let it be here. Okay. Now we need to find I1. Okay. So using parallel access theorem, using parallel access theorem, I1 would be equal to Ix plus area times whatever this distance is. So this distance is equal to what? D by 2. So here it would be D by 2 square. So Ix is 20 into 40 cube by 12. Area of this body is BD. BD is what? 20 into 40, and D is 40 by 2 square. Okay, so let's work it out. So 20 into 40 cube divided by 12. This is like 1.07 into 10 to the power 4, 3, 5, 5 plus this is 20 into 40 into 20 into 20, and this is 3.2 into 10 to the power 5, right? So finally it would be equal to 4.27 into 10 power 5 mm4. So our answer would be option D. Himani gave answer as option B, and that is only just this Ix. So that is not according to the question. Question asks, we need to find the moment of inertia about the axis passing through the base of this shorter dimension. So this is the question. The answer which you gave is corresponding to the center. I hope this clarifies. So if anybody has doubt, we can work it out, or we'll move on. Okay, moving on to the next question. Question 6 says the polar moment of inertia of a circle with diameter d is, and the options are pi d4 upon 64, pi d4 upon 36, pi d4 upon 16, pi d4 upon 32. So yeah, Himani has given answer as option D. What about others? Mangchen? Uh, okay, so as just now I said about this uh, here, polar moment of inertia. So using perpendicular axis theorem we can find. So in this case, the polar moment of inertia, we can derive it by taking, suppose, polar moment of inertia. So we have a circle, okay, and the center is this. We need to find the moment of inertia, second moment of area about this point, this axis, which is out of this plane. So how would we find it? Suppose take a strip at a distance r, which is having a thickness as dr, which is having a thickness dr. So what would be the moment of area of this small element would be equal to r square and the area of that element, right? So I'll just write this as di. Oh, So, and that would be the area of the small element would be what? R square dA. dA would be 2 pi r dr. Circumference of this strip into the width. So 2 pi r dr. So this is the second moment of area of this small strip. So if you want to find the polar moment of inertia of this complete thing, complete circle, so we need to integrate it through the complete domain. So for that, on integration, we just need to do 2 pi r dr, and integration will take from 0 to capital R. Okay, where capital R is d by 2. So what would uh, the result be? So this would be 2 pi r cube dr 0 to r, and that would be 2 pi r to the power 4 by 4, and the limits will be 0 to r. So that would be equal to pi r, yeah, r 4 by 4, so pi r upon 2. So this is the answer. In terms of d, it would be pi, substitute d by 2 here, 4, 2. So 2 to the 4, 4, 16. This would be equal to pi d4 upon 32. So either this would be the answer or this would be the answer. So answer would be pi d4 upon 32. Okay, I hope you can get this. What if I ask like what would be the moment of inertia about the axis running through the plane? I mean, yeah, this polar moment of inertia is about this axis which is out of this plane. So what if I ask this x? Suppose this x. So what would be ixx? Yes, yeah, Himani has given a correct answer. It would be pi d4 upon 64, and that would be how, like Ixx, due to symmetry of this system, Ixx would be equal to Iyy, and Io is equal to Ixx plus Iyy. This is equal to 2 times of Ixx, so Ixx would be equal to I naught upon 2. So yeah, you're correct. Let's move on to next question. Okay, so seventh question is the forces which meet at one point and their lines of action also lie on the same plane are known as. Options are coplanar concurrent forces, coplanar non-concurrent forces. Option C is non-coplanar concurrent forces, and option D is non-coplanar non-concurrent forces. So, what do you think? What would be the answer? Yeah, so everyone has given option A. So yeah, it's correct. It's we can see. Answer lies in the question itself. So it says on the same plane. Same plane would imply coplanar, and the line of action also sorry meet at one point. So that would imply they are having concurrent in nature. So this also implies through that. So answer is consequently coplanar concurrent forces. Let's move on to the next question. So for evaluation of member forces in a plane truss by method of joints, maximum number of unknowns at a joint should be, and options are 4, 3, 2, 1. So what do you think? I hope you guys all know the method of joints. No one? Wang Chen has given answer is 2 or option 2. Okay. Yeah. Okay. So you guys know option C. That means answer is 2, and that that is uh, if I would ask like why would you think like answer would be option 2? So can anyone any of you unmute yourself and try to give the answer? No moment. Yes. Yeah. So in this, yeah, you guys have some idea for sure. Yes. So, uh, yeah, in the method of joints, since it's a truss problem, and moment degree of freedom won't be there. So at a point, uh, we would like to find what sigma fx is equal to sigma fy equal to 0. So when we have only two equations, so we need to have only two unknowns at most, then only would be able to solve the equation. So yes, answer is option 2. Okay, it's the next one is a very easy question. Let's see. So two forces P and Q act at a point and the angle between them is 60 degree. The resultant of the forces is, so what is the answer? Uh, Wangchen has said as option B. What about Himani? Uh, Himani, if you are trying to solve it, I'll wait. Otherwise, I'll try to give the answer. Okay, I'll try to. So, since Wangchen has said option B, let's try to solve it whether it's correct or not. So, we are given a system. Uh, Two forces P and Q act. So, let's see. P and Q act. The angle between them is 60 degree. We need to find the resultant of this forces. Like, if this is the resultant R, what would be the magnitude? Okay, so Imani has worked it out and said as option C. Okay, so I'll try to solve it uh, using two ways, like using directly conventional way, or and I'll try to solve it in a different way also. So conventional way follows like using parallelogram theorem. So how will it be is you just complete the parallelogram. So this is like Q, P and Q. So the resultant is R, and and the value it gives is as straightforward as like p square plus q square plus 2pq cos theta, where the angle theta is the angle between them. Okay. Okay, and this would give me p square plus q square plus 2pq cos theta. So here we have theta as 60 degree, that is equal to 1 by 2, and that would give me p square plus q square is equal to pq. Okay, so this gives the answer as option C. Okay, what if we don't know the straightforward this formula? So we can work it out more formally. So we don't need to remember this formula, we can work it out. So we had this uh, P, right, and Q. Okay, now angle is 60 degree. So we can convert this Q into components. So one component along the P, that would be Q cos 60, and one perpendicular to it, that would be Q sin 60. Okay, so now straightforward, say it being a perpendicular, like normally it would be P plus Q cos 60 square plus Q sin 60 square. Now substituting the values, P plus Q by 2 square, Q root 3 by 2 square, this would be P square plus Q square by 4 plus 2 times P into Q by 2 plus 3 Q by 4, and this would result into P square plus Q square plus PQ. So again, answer is option C. I hope Wang Chen, you don't have any doubt in this regard. If you have any doubt, okay, yeah. Now next question. D'Alembert principle. D'Alembert's principle is used for, options are reducing the problem of kinematics to equivalent statics problem. Option B is stability of floating bodies. Option C is designing safe structure, and option D is none of the above. So what do you think? What's the answer? It's a straightforward statement. Don't know. Okay, so I'll just tell the answer is option A, and uh, this can be thought of as in the conservation of momentum thing. So this is a straightforward thing. D'Alembert's principle is used for reducing the problem of kinematics to equivalent statistics problem. So what do we take normally in this case? It's just an abstract way I'm trying to tell you is, moment, linear momentum is equal to mv, mass times velocity, and uh, uh, this dp by dt is equal to force, and this is like dmv by dt, like dm by dt times velocity, and uh, dv by dt. So this is what it is. You guys can search more on this so that you get the better idea more yourself, and you can ask in the later session also, like if you got it or not, or if you have any certain doubt pertaining to it. Okay, question number 11 is uh, what is kinetics? Options are branch of dynamics which deals with studies of bodies under motion without considering forces. Option B is branch of dynamics which deals with the study of bodies at rest. And option C is branch of dynamics which deal with the study of bodies under motion by considering forces. And option D is none of the above. Option A by Wang Chen. What about Himani? I think this thing must be known by you all. Option A. Actually, answer is option. Answer is option C. In the kinetics, we study the forces under motion with the effect of forces. We consider forces. Then only you would be able to study the motion. Otherwise, this is kinetics, right? Otherwise, it would have been statics. Okay. Uh, okay. Next question pertaining to motion. A body of weight W initially rests on a flat horizontal surface is pulled by a horizontal force P. As a result, the body comes in motion. If the coefficient of static and kinematic friction between the body and the surface is μs and μk respectively, the resisting force will be. The options are μs P, μs times W, μk times W, and μk times P. Better observe that mu s is static friction, coefficient of static friction, and mu k is coefficient of kinematic friction. Okay. So what do you guys think? What is the answer? I'll try to draw the free body diagram of this question. So suppose this is the ground. We have a body of weight W on a flat horizontal and it's pulled by a force F. Okay, let's draw this with a different. By pulling this, the force F. So, okay, P, sorry, it's P. So, as a result, the body comes in motion. If so, we need to find the. Okay, so when is it in motion? There would be a resisting force developing, right? Friction force F. So we need to find what this friction force is. Himani has said answer as option D. I would say please see. You can you have still option. You can see. Uh, I don't know about others. What do you think? What would be the answer? Yes. Okay, I'll solve it when you guys are having doubt. Okay, since this body is having a weight, so the body force, gravitational force weight is W acting downwards. Consequently, the ground will give a reaction force R, right? And what this R would be equal to? W. Okay, and P, sorry, this F would be what? Since this is in motion, right? So static friction is not into play, kinetic friction is into play. So mu k times reaction. This is what is the formula for for friction, right? So mu k times W. This is what is the resisting force. Okay. So answer is option C. I hope Himani has got the correct answer. Okay. Moving on to the next question. Find the centroid of a trapezium whose parallel sides are A equal to 40 mm, B equal to 80 mm, and the distance between two parallel sides is h equal to 60 mm. And options are as given. So I'll draw the diagram and I'll wait for some time to let you guys do, or okay, let's see. Let me draw the diagram first. Okay, draw it more properly. This is A equal to 40 mm, B equal to 80 mm, and the distance is h equal to 60 mm. Okay, so where the centroid would be, that is the question. Like this body has a centroid, right? Say, so where would it lie? That we need to find. So any of you, like, unmute yourself and just try to give just like how would you proceed to find the centroid? Any of you? Anyone? Himani? Or you can just type in. Okay, you're solving. Himani is saying. Uh, Without solving it, you can just try to say how would you proceed so that I can then because nonetheless I will solve it for you all, but saying like if you guys know or not. Hint I can give is you can consider it as in a different section. Okay, uh, can we solve it by direct formula? Yes, you can, but it's best if you guys know the basics, because rather than mugging everything, if you know the basics and try to find as quickly as possible, that would be very much easy, right? If you rather than which you can find it easily, storing that formula and all, you can try to remember other things. That's what I think, because I don't really remember the formula of this, so I'll try to find it using the basic thing. Okay, while Himani is solving, or maybe others also are solving, I'll also solve for you all. So I have divided this trapezium into three sections. Let's say this is as A1, this is as A2, and this is as A3. A1 is a right angle triangle, A2 is as a rectangle, and A3 is also a triangle. Okay. To find the centroid, if you guys know, suppose I want to find from this. Suppose I take this small x, okay, as my origin. So I'll everything I measure from here. Okay. Okay. Himani has solved and said option A. Okay, we'll work it out and tell. Let's do it. So, uh, if you guys don't know how the centroid is found. It's like uh, suppose R bar is A1 R1 plus A2 R2 plus A3 R3 by A1 plus A2 plus A3. I hope you guys know this formula. Okay, so let's solve it. A1 is area of this right angle triangle, and that would be half into base would be, so this is 40, so this would be also 40. Now total is 80, dividing it into two parts it will be 20, here also 20. Okay, so base would be 20, height is 60, so area is 60. Okay, now R1 is the centroid of this triangle from here, from this. Okay, so you must know that uh, so this from the shorter base, it's 2 by 3 of, oh sorry, it's h by 3, one third of the height. Okay, so that is one third of 60. Now A2 is this rectangle that is having an area as 40 times 60. Okay, you guys can pitch in wherever I make a mistake or you guys have any doubt. Okay, so A2 is 40 times 60 and R2 is what? So since it's a rectangle, it is having a symmetric section, so it would be h by 2, right? 60 by 2. And A3 is similar to A1, so area would be half into base into height, and R3 would be same as R1, and that would be one third of 60. Okay, divided by area of all these sections. So 120 plus 40 into 60 plus 120 60. Okay, so what I have calculated, R1, R2, R3. Okay, I'm trying to find R now, R bar. So okay, let's try to make it as a common thing. So since this and this things are having a common, so this becomes twice and twice, so half gets cancelled, so I can write 20 into 60, one third of 60 is 20, right? Here 40 into 60 into 30 divided by, so here this half and half, so 20 into 60 plus 40 into 60, I can cancel 60, 60, 60 common all throughout. If I take it as a common, I'm trying to do it directly, don't get mistaken. So 2 to the 4, 400, this is 1200, and 40 plus 20, 60, 1600 upon 60, that is uh, 80 upon 3, right? Mm-hmm. 80 upon 3, yes. So we can write it as 3 to the 6, 20, 26.67 or 66, okay, meter, millimeter. So this is from here, right? So 26.6 mm from B side, This one. I took my origin as B, right? So from B it is 26.6 mm. What would be from side A? So side A, from side A. So if it is this one, so it would be 60 minus 26.66 from A, and that would be 33.33 mm from A. Okay, so answer is 1 of or 26.67 from B. So with this, answer is option A. Okay. Yeah. Lakshman has raised the hand. Yeah. You can unmute yourself and ask question.
Sir, can we use this formula for all shapes?
Yes. Yes. Yeah. This formula, right?
Yes, sir, that formula.
Yes. It's a
Okay,
general one.
thank you.
Yeah. Okay. Okay. Moving on to the next question. Or if I don't know if you guys, other guys, you guys have any doubt to this question. If you guys have any doubt, you can ask me anytime. Okay, let's move on to the next question. Question number 14 is the resultant of two coplanar forces P and Q such that P is greater than Q acting along the same straight line but in opposite direction is given by. It's quite easy. If you guys cannot say directly, also we have solved using parallelogram theorem, so you can try applying through that also. So what do you think, what is the answer? I'll give you guys time. Imani is saying option B. Are you sure? Because it's a question mark. Others? Okay. Two of them has given answer as option B. Ashita has also given as option B. Okay. Uh, Most of them has given as option B. Yes, it is the correct answer. Let's see through the. Let's work it out as given in the question. So, given in the question is P. Suppose P acts. Q is acting along the same straight line, but in opposite direction of P. That means Q is acting like this. Okay, and P is having greater magnitude than Q. Okay, so using like uh, it would be directly, but directly using the formula also we can calculate 2pq cos theta. So what would be p square plus q square plus 2pq? What is the angle between them? It's 180 degree, right? Yeah, cos 180, and cos 180 degree is minus 1. So this would give me p square plus q square minus 2pq. And you know the formula pertaining to this is equal to p minus q whole square root r. It could be q minus p whole square root also, right? Or I'll write I can move it and say P minus Q mod. But since we know P is already greater than Q, right? We can directly write it's P minus Q. Okay. The answer is P minus Q. Okay. These were the questions pertaining to assignment 0. Let's work with some questions pertaining to assignment 1, and after some time we'll again do some questions relevant to assignment 0 only, since I see that most of them has some basic problem also. So okay, we'll work it out that too also. Okay, so questions related to assignment 1. Question is, normal stress on a principal plane is, options are maximum, minimum, 0. Option D is either maximum or minimum. Himani has given answer as option A. What about others? Mongchen has given option answer as option C. Option C, 0. Others? Harshita, Lakshan, Ravinder, C. Okay. Anyone else? Okay. So one of them has said as option A and two of them has said as option C. It's neither this, neither this. Answer is option D. Okay, let's see why option C is a wrong answer. Normal stress on a principal plane. Principal plane has a feature where shear stress is 0, not the normal stress. Normal stress can be 0, as in the minimum case or maximum case, but not specifically 0. That is the case for uh, shear stress. The definition of principal plane is like that only, right? Now, how would you say like either maximum or minimum? So, uh, suppose this is principal plane sigma 1, sigma 2, sigma 3, as there are no shear stress involving. So, both of them are principal plane, and uh, both of them are normal stress, right? But uh, if you see like the principal stresses, it could be like sigma 1 is greater than sigma 2, right? So one of them would be maximum or minimum. Or uh, I don't know if you guys have read about the Mohr circle, or no, you guys still have not come across. So it's just you would see that this is either maximum or minimum. Okay, this is the answer. This is straightforward. That this won't be the case, because this is the case for shear stress, not the normal stress. Okay, this question is already there in the assignment, so I will skip this. This is the same thing. It is also having the likewise for this. Okay, in, let's see this question. There is an axial force of 90 kilonewton. It's applied to a solid. Uh, it's applied to solid cylindrical shaft of diameter 40 mm. Determine the normal stress due to actual load in the shaft. Okay, so what do you think? What would be the answer? I'll wait for 5 minutes. 5 is a bit more. I'll just say 2 minutes. If you guys can give the answer. Meanwhile, I'll draw the free body diagram. Okay, so there's a solid cylindrical shaft. I'll try to make it big. The force applied is 90 kilonewton. And the diameter is this is 40 mm. We need to find the normal stress. Okay, Himani has given answer as option A. Let's see. Meanwhile, others can also try, or if you guys don't know, okay, let's see. Normal stress would be what? Force acting upon the area, normal area. So this is a normal force acting to this plane, right? So P is 90 kilonewton and area of a circle is what? Pi by 4 d square, right? Pi by 4 d square. That is, I can convert it into 10 to the power 3 Newton. And this is pi by 4 d square. D is 40 mm. So this is Newton per mm square, right? Let's solve this. So sigma n is 90 into 10 power 3. This 4 will go up. This is pi into 40 square. Let's solve it. 90 into 4 into 1000 divide by pi and divide by 40 square. Answer come out to be 71.62 Newton per mm square. That is 71.62 megapascal. This is the answer. Okay, Mani. Initially, you said option A, and then you're saying option B. What did you do wrong? Yeah, you can unmute yourself and say. Mani, you can unmute yourself. Yes, am I audible, Himani? You raised your hand. You can unmute yourself and say what you want to say. Yeah, you can unmute yourself and say what was that mistake? Okay, you forgot to convert kilonewton to Newton, but that would still the value should be uh, like Newton per mm square, the megapascal, only into 10 to the power something. 3 should matter, right? 71.62, but there is no values closer to this thing. Maybe rounding off error also.
Sir, this hastiness, nothing.
Yeah,
Sir, this hastiness.
I still didn't get you.
That was the mistake.
Okay, okay, no problem. I hope this clarifies. So correct answer is option B, 71.62 megapascal. Okay, moving on So next question. This is a question similar to what is given in the assignment, so this will help you a lot. The question is, a 10-meter long steel wire with circular cross section that is 5 mm in diameter is subjected to an axial tensile load of 5 kN. The elongation in the wire is Young's modulus of elasticity is given as 200 GPa. The options are 3.42 mm, 7.64 mm, 12.72 mm, or 6.36 mm. So I'll wait for some time. Meanwhile, I'll draw the FPD pertaining to this problem. So let's again draw this. Suppose I continue this thing here. Apply force of 5 kN. Circular cross section, this is D. D is 5 mm. Okay, and length is D is 5 mm, and this is the length. And on the application of load, the body will elongate a bit, that is delta L. And okay, so Wang Chen has given answer as option C. Okay, what about others? Okay, I'll try to solve it. There is a direct formula PL by AE. Delta L would be PL by AE, but rather than directly saying, I'll just say strain is what? Sigma stress upon Young's modulus. Yeah, this is what is Hooke's law. Sigma upon E, and stress is P upon A, right? And strain is change in length upon original length, and this is this. Okay, so delta L would be PL upon AE. This is now substitute values and see, you should substitute values correct to the units. Okay, so P is in kilonewton, 5 kilonewton. I would convert into Newton. Okay, so multiplied it with 1000. Length is 10 meter. L is equal to 10 meter. I would write it into everything as mm. Okay, so 10 into 10 to the power 3 mm, right? 10 into 10 power 3. So you see, everything I'm using as Newton or mm. Okay, so in the numerator it is what? Newton mm is there, right? Yeah. Denominator A, area is pi by 4 d square, and d is 5 mm. So 5 square, this is mm square. I'll write it here, times. Now E is 200 GPa. Okay, let's write it here. E is 200 GPa. Okay, so if I convert into Newton per mm square, right? Before that, in terms of megapascal, it would be 10 to the power 3 megapascal, right? Gigapascal is 10 to the power 9 pascal, and megapascal is 10 to the power 6 pascal. So if I convert gigapascal into megapascal, it will be 10 to the power 3, and 1 Newton per mm² is equal to 1 megapascal. So this is 2 into 10 to the power 5 Newton per mm², right? So I can write it here, 2 into 10 to the power 5 Newton per mm². Unit. I'm writing it so that you can get the clarity on the units also. So see here, Newton gets cancelled out and mm² get cancelled out. So our dimension is correct in this sense, like would be the answer. Now let's try to solve the numerical values. So this would be okay. So here 10 to the power 3. Here we have 10 to the power 5. Okay. So 3, 500, because 3, 4 and 5. So this should get cancelled out. 5 by 4, 25 into 2 mm. Let's solve it. 500 into 4 divided by 5 and divided by 50. It's 12.73 mm. So Himani and Wangchen, Himani, Harshita gave answer as option C. Let's see. Yes, 12.72 mm. Yeah. So you guys are all correct. Answer is option C. Okay. Let's move on. Okay. So this question is already there in the assignment. I'll try to convert this question into a different sense so that you guys can solve it in the assignment. Let's move on. Okay, this is a tricky question. It looks tough, but it's quite easy. Question is, a car weighing 100 kilonewton. A car weighing 100 kilonewton, when fully loaded, is pulled slowly up a steep incline track by a steel cable. The cable has an effective cross-section area of 250 mm² and the angle of inclination is 30 degree. Calculate the tensile load in the cable, considering that no friction exists between the surface and the car wheel. So you're seeing here, this is an inclined plane with inclination of 30 degree. This is a trolley and this is the weight 100 kilonewton acting. Okay, and through this cable we are trying to pull it upwards. So we need to find what would be the tensile stress acting on this cable. So meanwhile you guys solve it, I'll draw the FPD. Okay. So this is the thing. I'll just convert it into like this. Weight W. Okay. Tension on the cable. Yeah. And the reaction force from the ground or the inclination to this. So inclination is 30 degree. W. How do you proceed? Because most of the thing I have depicted. One of you can just unmute yourself and just say what will you find and then what you will substitute to get what the answer, like tensile stress.
Components of W.
Yeah, component of W along. money. Okay, so as she said, component of W. So there are two components of W. One is okay, let's see, this angle is 30, 60. So this is W cos 60 and this is W cos 30. So which one?
W cos नहीं नहीं opposite to T, which is opposite to T.
Yes, this one. W cos 60. Yeah. So we just need to find this tension. What is the tension acting on this cable? So that is W cos 60. Okay, I hope nobody has doubt in this. Okay, W cos 60. And to find finally the tensile stress, to do that, sigma T, you just need to substitute T upon A, and that is W cos 60, and area of this cross section of the cable, that would be pi by 4 d square, right? The cable has the dimension of circle, right? So W is having a weight as 100 kilonewton. 100, I'll just convert it into a newton. So 10 to the power 3 cos 60 divided by area is pi by 4 d square. So you guys are seeing, right? I am peculiar about these units also. So I am converting kilonewton into newton and every length dimension into mm, so that I can keep everything into newton per mm square or everything like that, so that it would be easy to convert everything into megapascal or millimeter. Okay, so our radius or diameter is okay. So we are already given the area of the cross section as 250 mm square. So we don't need to do this thing. Area is 250 mm square, right? So Newton per mm square is what we are having. The answer would be okay. So this is I'll just write it like this, then 100 to 50 cos 60 is 1 by 2 Newton per mm square. By hand I can do this, this and this. So this will be 200 Newton per mm square. That would be 200 megapascal. Yeah, Imani has already. So answer is 200 megapascal. Okay. Hope it's clarified to everyone. You guys can pitch in whenever you feel you are having doubt. You can raise your hand. Okay. Moving on to the next question. Okay, so this question is a good one. So, four 20 mm diameter rivets join two plates of width 120 mm and thickness 10 mm. The allowable stresses in bearing of the plate and shearing of rivet are 100 megapascal and 50 megapascal respectively. The maximum safe load P in kilonewton that may be applied in shearing failure of the rivet and bearing failure of the plate respectively is kilo and everything answer should be in kilonewton. Okay, so this is a tricky question. I'll try to solve it. If you guys feel you can solve it, you can do it hand in hand. Okay, let's Let me solve it. So first question is asking is maximum safe load in shearing failure of the rivet. So maximum allowable stress in shearing of rivet is I'll just write sigma s as 50 megapascal, right? So area involved in shearing is like uh, so this is a rivet, right? In shear, this section is involved pi by 4 d square, the cross section of this rivet itself, pi by 4 d square. Okay, and since there are 4 rivets, right? So we will multiply with 4. Okay, so P would be sigma s upon sigma s into as, and that would be 50 see megapascal, so Newton per mm square, and this would be in, okay, like I'll just substitute 50. What is the diameter? Is 20 mm diameter, so 20 square. Okay, this is in mm square. Okay, now 50 times uh, pi into 20 square, so Newton per mm square, this will be answer in Newton, right? So 50, see, 50 into 400 times pi, answer comes out to be 62831.8531 Newton. So convert it into kilonewton, it would be 62.831 kilonewton. Okay, next is in shear. Uh, what would be the answer in bearing? Okay, uh, allowable stress in bearing. This is in shear. Shear. Now in bearing, uh, allowable stress in bearing is 100 megapascal, and area involved in the bearing resistance of this bearing failure is so uh, in bearing, there is a plate, bearing failure happens in the plate itself, and the cross section involved is diameter times thickness of the plate, where the diameter is the uh, diameter of the rivet. Okay, so this is d times t, and since 4 rivets are involved, so it would be 4 times of d times t. Okay, so 4d, diameter is 20 and thickness is this one. Oh, no, thickness is 10 mm, right? So 10, that is 200 800 mm square. Okay, so consequently allowable load in bearing failure is sigma b times AB, that is 100 into 800, and this would be in Newton, that is 8 kilonewton. 8 into 10 to the power 4, 80 kilonewton. Okay, so let's see Is it yeah, so 62.831 and 80, option B. Okay, so Himani also gave answer as option B, so that confirms my proof of this question. Okay. Hmm. Okay. Next question is relating to this question itself. Next question asks, in the above question, determine the safe load if minimum average tensile stress in plate is 15 megapascal. So this is like tensile stress. So kind of tearing of the plate will happen because of this, right? So for this net cross section of the along the width of the plate comes into effect. So answer would be, so for the tensile case we are given with sigma T as 15 megapascal, right? 80 involved would be, so along the cross section, so along this cross section, so net area of the cross section is involved in the uh, resistance of this tensile failure. Okay, so let me draw it here. So is this like, so along this cross section I want to find AN. Okay, along this cross section AN or AT, yeah, 80 would be what, width of the, suppose B, width of the plate B, this is D, so B minus D minus D times the cross section, like along this depth, so thickness. Okay, so we are given with the width of this plate as 120 mm here. So 120 mm, diameter of the rivet was given as 20, minus 20, and thickness of the plate is given as 10 mm. So this would be 180, 800. Correct me if I'm wrong. Okay, 800 mm square. I didn't make any mistakes before. Okay. Consequently, Pt can be found as sigma T times 80, and that is 15 into 800 Newton. So that is 15 8 120, and two more zeros, Newton, that is 12 kilonewton. Okay, yeah, option B. Okay, moving forward. Okay, this question, in the figures shown, the average normal stress and average shear stress on the inclined plane ABEF respectively are. So here uh, in this cross section we need to find what would be the normal stress. So in this plane, inclined plane, there is a sigma n, that is a normal stress, and tau shear stress acting on this plane. So the question asks what are the values for those stresses. So let's try to solve that. I'll try to draw this like this. So let me draw this cross section here. So we're given with this, okay, A, E, A, E, with this as 30 degree. Now force given is 50 Newton here. Okay, we need to find sigma n, that is normal stress acting on this plane, and tau, average shear acting on this plane. Hong Chen gave answer as option A to this question. Okay, let's work it out and see whether you are correct or wrong. So this is it. Now let's see what are the other dimensions provided. So this height, this is the height is 2 mm, right? And the width of the cross section is 4 mm. Okay, so I'll just use notation now as B as 4 mm, H as 2 mm. Okay, so this is H. Okay, now let's try to find first what is the area of this plane. This plane, what is the area of that plane? So for that, first let us find what is the length of this incline. Okay, and that would be, so this is H, this is 30. Okay, so let's say if I say it is as X, so X cos 30 is equal to H, so X would be H upon cos 30. Okay, uh, let it be like this only, so X is H upon cos 30. Okay, now area of this inclined plane would be, let's say, whether area of the inclined plane A equal to, so X times width, right? And this would be equal to H upon cos 30 times B, that is 4. In this case, let me write as B. Area uh, area is equal to H is 2, cos 30 is root 3 by 2, and B is 4. So 4 to the 8, 16 upon root 3 mm square. Let it be like this. Okay, now we have found out the area of this inclined plane. Let's see, we have to find the normal stress and average shear stress acting on this plane. To find the normal stress, we need to find the normal force acting on this plane. Okay, so on this plane, 50 kilonewton, this is 30-degree inclination, right? Yeah, so 50 kilonewton is acting horizontally, but we need to find the forces normal to it and along the plane. So for that, let us resolve this force into one along the plane and one normal to this plane. Okay, so one normal to this plane and one along this plane. I'll write it as Pn and this as Pt, Peta. Okay, so what will it be? So before that, let's find what is this angle. So this is 90, mm, this is 60, so this would be 60, so this is 30. Okay, so that means Pn is 50 cos 30, that is 50 to root 3 by 2, that is 25 root 3 kilonewton. Don't forget the units. Okay, and P tau is 50 cos 60, that is 50 into 1 by 2, 25 kilonewton. Okay, so forces are also resolved. Now we just need to calculate the stresses. So average normal stress and average shear stress. So for that, to calculate average normal stress, sigma n would be the normal force acting on this plane upon area of this plane, that is 25 root 3. Area of this plane is 16 upon root 3, right? And this is kilonewton and per mm square. So this would be like 25 into 3, 75 upon 16 into 10 to the power 3 Newton per mm square. That would give me megapascal. So answer would be 75 upon 16. It is equal to 4.6875. Okay, into 10 power 3 square. So 468.75 megapascal. Please do pitch in if I make anywhere mistake. Okay, and it really seems I am making a mistake. Okay, so mistake is it's given as Newton. I took here as kilonewton. Newton. So these all things would be in Newton. So Newton per mm square, that is megapascal. So this is 4.6875 megapascal. Average shear stress, tau would be P tau upon area, and that is 25 upon 16 root 3, 16 upon root 3, and this is equal to 25 divided by 16 into 3. So this would be equal to 2.706 megapascal. Okay, so let's match it up with the answer. So 2.706 has a shear stress and 4.6875 as normal. So 4.68 and 2.706. Option C would be the correct answer. Okay, please have a look, and uh, if you guys have any doubt, you can ask in this question also. Okay, we'll move on to the next question. This question is also there in the assignment, so uh, I'll try not to solve this, but I'll just give you a hint. You can use the invariance to solve the answer for this question. Okay. Now since we were trying to solve uh, assignment 1 problem, now let's again solve easy questions of assignment 0. Okay, we'll solve this quickly. So let's do this. The question is unit of first moment of area is, and options are kg meter square, meter to the power 4, kg per meter square, and meter cube. So what do you think? What is the answer? Let's see if you guys are still there or not. So anyone? Wang Chen is saying we did this already. Uh, I would deny. This is not okay. I'll just show the question what we did earlier. Hmm. See, the question was second moment of area. Question which we are trying to do now. Hmm. It's first moment of area. Okay. So Harshita has given answer as option D. What about Himani? I'll just write L. First moment of area is R plus A, and it has a dimension as this has a dimension, R has a dimension as meter, dimension as length, so unit would be meter, and area has a dimension as length square, so it would be meter square, so this would be meter cube. Okay, so as Harshita and Himani also gave the answer, its answer would be option D, meter cube. So I think Wang Chen, you can see the difference here. This is the first moment of area, not the second moment of area. Second moment of area uh, had the unit as meter to the power 4. Okay. Which of the following is the SI unit of force? It's a pretty straightforward answer. You guys can give the answer in the chat box. kg meter square, kg meter square per second, kg meter per second square. Yes, D. Yeah, answer is D. It's quite easy. Force is what? Mass times acceleration, right? Mass has a unit as kg, and acceleration is what? Meter per second square. So kg meter per second square. Exactly. Okay. Yeah. Everyone has given answer as option D. That's good. Moving on to the next question. I have taught you like earlier the units were different, so I hope you guys can give the answer pertaining to this question. The moment of inertia about x and y axis of a planar section are 5 meter to the power 4 and 4 meter to the power 4 respectively. The polar moment of inertia is Yes, Himani has given her answer. Others, this will use perpendicular axis theorem. I already uh, I already solved a similar question previously, so I hope everyone can give the answer quickly. The answer is C only. So I O or I P whatever be is equal to Ix plus Iy, and that is 5 plus 4, that will give me 9. Okay, moving on to the next question. This is also done, right? Poisson's ratio is the ratio of lateral strain to longitudinal strain. And this, okay, so this question is similar, but slight twist. Earlier, question is the similar thing. We need to find the moment of inertia for a rectangular section of size 20 by 40 mm about the axis. But the difference is, earlier the question was the axis was passing through the base of the shorter dimension. This time the base, we need to find the axis is passing through the base of the larger dimension. So you guys solve it and let me know what do you get. 40, 20. So, okay. Himani and Harshita has given answer as option B. One can also. Okay. Let's see. If you guys are correct, then that would make me proud about it. So, answer, let's say this is x, and we need to find about this small x, right? This distance would be 10. Ix is 40 into 20 cube by 12 mm 4. Okay, so I small xx would be 40 into 20 cube by 12 plus area of this cross section, that is 40 into 20, and the distance between these two axes, that is 10 whole square. 40, say 40 into 20 by 12 plus 80 into, answers come out to be 3.47 into the power 4 mm4, right? Moment of inertia about the axis passing through the base of larger dimension. 40 into BD cube by 12. 40 into 20, and this, what did I make? Did I made any mistake? 40 into 20 cube, 2.67, and 40 into 20 to 20. Oh, sorry. It would be equal to 1.067 into 10 to the power 3 to 5 mm to the power 4. Yeah. So yes, most of them was correct answer, option B. That's good. Let's move on to next question. the moment of inertia of a circle with diameter d is. So I am asking the moment of inertia of a circle. I am not saying the polar moment of inertia. Okay. So lastly, I asked like polar moment of inertia. To that answer was pi d 4 by 32. So consequently, I also asked what would be the moment of inertia of circle along that plane, and you guys gave the answer as pi d 4 by 64. So yes, you guys were correct. Pi d 4 upon 64 is the correct answer pertaining to this question. So let's move on to the next question. And this is also done. Next, this is also done. Okay, yeah, this one. Two forces P and Q act at a point and the angle between them is 90 degree. The resultant of the forces is pretty straightforward. A, P and Q acts and angle between them is 90 degree. Yes, answer is P square plus Q square. Even if you use parallelogram theorem, it would be like P square plus Q square plus 2PQ cos theta, and cos theta is cos 90 over here, and this would be equal to 0. So finally R would be equal to P square plus Q square. Okay. Next question. This is also done. This is also done. This is also done. Okay, that's it for today. Yeah. That's it for today. You guys can ask any doubt if you have pertaining to the lectures of this week, or today's session. Also, you can speak if you have any doubt pertaining to today's session. And also, if you guys are not able to have any doubts now, and you feel like you are having doubt, you can post it in the discussion forum also. Okay, so I'll uh, just slowly move on from the top, so you guys can ask question if you feel like it. Okay, Himani is saying prerequisite for next session. Okay, so you guys better be ready with the second, because I'll give just like today I gave a hint just for solving assignment 1. I'll give you the gist for solving assignment number 2, and I'll also try to solve more questions. I'll also try to solve more questions of assignment 1 also. Assignment 1 related problems. I'll start with a few questions of assignment 1, then again I'll solve assignment 2 related problems. Okay, so it stopped sharing. I'll start again sharing. So okay, I'll just move it quite quickly. that's it. Okay, I hope nobody has any doubts. If you feel like you have some any problem, you can post it in the discussion forum, or you can ask me in the next discussion session. That would be in the next week on the same time, Saturday 4 to 6. Okay, so can we close the session now? Harshita and Wangchen, can you give the information whether we can close the session now? Okay. Yeah. Okay. See you next week, same time. Bye. Take care. Have a nice day. Ending the session now. Yeah. You're welcome. Bye. Take care.